Hello, this is FlippedHarber for Algebra 2. In this video, we'll cover Section 2.6, Transforming Linear Functions. Now, the idea of transformations will be a common one through this course, but we're just going to apply it to each type of equation separately. So we're starting by transforming linear functions because that's what we've been talking about, is linear functions. Alright, so our objectives for this lesson are to transform linear functions. And then we want to solve problems involving linear transformations. The topics we'll include are different types of transformations. The three types are translations, stretches and compressions, and reflections. Now, a translation is when we shift the graph up, down, left, or right. The slope of the graph does not change under this translation. Now, whenever we want to shift horizontally, we're going to add or subtract a number to the x value. Whenever we want to shift the graph up or down, we're going to add or subtract a number all the way at the very end. Okay? I like to refer to this as inside changes and outside changes. When we change the x value itself, I refer to that as an inside change. When we add or subtract all the way at the end, I like to refer to that as an outside change. And that's something we're going to stick with through this whole class, are these inside changes and outside changes. Now, reflections, we either reflect across the y-axis or we reflect across the x-axis. This does change the slope of the graph. In order to reflect across the y-axis, we multiply the x value by a negative. Now that's an inside change. Whenever we reflect across the x-axis, we multiply the whole function by a negative 1. The whole thing gets multiplied by the negative 1. Not just the x, but the whole equation. So again, inside changes and outside changes. Stretches and compressions are probably the most challenging of the two. When we horizontally stretch, you want to think about the points on the line being pulled horizontally, or if we're stretching them, they're being pushed horizontally. When we talk about a vertical stretch or compression, we need to think about the points on the graph being pulled or pushed up or down. Now, when you talk about a horizontal stretch, the y-intercept does not change. That y-intercept stays exactly where it was at. A horizontal stretch or compression is an inside change. A vertical stretch or compression, the x-intercept doesn't move. And the vertical stretch or compression is what I refer to as an outside change. Now, notice that horizontal stretches and compressions, they show it as division. Another way to think about it is when we multiply inside, it compresses it. When we divide inside, or when we multiply by a number that's smaller than 1, that stretches it out. I think it'll get clear as we go through some examples. Alright, let g of x be the indicated transformation to f of x, meaning we're given the function f of x equals 3x minus 4, and we want to move this graph up 3 units. We want to translate it up 3 units. What are we going to do to f of x to make it this new function g of x? Well, that vertical translation we need to add at the very end. So when we add 3 to the very end, we combine like terms, we get g of x equals 3x minus 1. Okay, not too bad. Let g of x be a horizontal compression of f of x by a factor of 1/3. We want to write the rule for g of x and graph the function. Okay, so a horizontal compression by 1/3. they're giving us this fractional number, and the way that they explain it is that you need to divide by 1/3. So we're going to take 1 over, and that b value is the 1/3. So really, what we're doing is inside with the x, we're going to multiply by 3. So inside with the x, we put a 3, so we have 2 times 3x minus 1. So only the x gets multiplied by 3, not the 1 at the end. So g of x equals 6x minus 1. Now they also want us to graph this function. So we mark our y-intercept, -1, and we use our slope. We go up 6 and over 1. Now here on my graph, you can see the original function f of x. You can see the new function g of x. It's a horizontal compression, so the y-intercept did not change. And g of x has been moved in towards the y-axis. All right, here's another one. Let g of x be a vertical shift of f of x equals x down 2 units, followed by a vertical stretch by a factor of 5. So we've got 2 different transformations that we need to make happen. We're just going to apply the rules in order. So first of all, to move it down 2 units, we're going to need to subtract 2. Then to get that vertical stretch, we need to multiply the whole function by 5. Now you need to make sure you do this in order, because if you do it out of order, you're going to get it wrong. So we start by subtracting 2. So it goes from x, it changes to x minus 2. Now that takes care of the shift. Now the vertical stretch, we have to multiply the whole function by 5. So in this case, because it's an outside change, the x and the 2 get multiplied by 5. So g of x equals 5x minus 10. All right, let's try a couple reflections. Let's reflect 2x plus 1 over the y-axis, and we'll reflect 2x plus 1 over the x-axis. So in order to reflect something over the y-axis, we'll put a negative inside with the x. To reflect it across the x-axis, we're going to multiply the whole function by a negative. So if we put a negative in there with the x, we get negative 2x plus 1. Just that first term got the negative. If we reflect over the x-axis, we multiply the whole function by a negative. We distribute that negative in, we get negative 2x minus 1. And it doesn't look like a big difference, but this is going to be a different graph for these two functions. All right, so we're all done. You've got the homework. Time to get to it. I'll see you in class, and I'll see you online.